In this model, we're going to examine approvals process. Specifically, we're going to look at doing approvals in series versus doing them in parallel, each configuration. The model was suggested to me by Bruce Fratto of GE Energy Management. He came across this a lot as part of his job, and he thought it would make an excellent training model for Lean because of the trade-offs involved. And I agreed with him, and so I constructed it. So here's what we have. Documents are going to come in here, and they need to be approved. At level 1, we got level 1 approvals here. Who's ever available will take it and work on it, and they're either going to accept it, approve it, or reject it. It goes to the next level, it gets approved or rejected, and then it goes to the next level, it gets approved or rejected. If it's rejected at a level, it immediately leaves the system and does not continue on for further approvals. We can control the rate that the approvals come in. I'm going to go here where it says arrival rates. I'm going to right click, say input editor, and there's a line down here. And if I look here, what this says is at 0 hours, the document should come in once per minute. At 9 hours, they should come in at once per minute. So at 9 a.m., come in once per minute. And at 17 hours or 5 o'clock p.m., come in at once per minute. Now we could change this if we wanted to. I could slow it down, for example, at night so that it only comes in, so that they come in once every 2 minutes. Okay, so now they're only coming in half as often. I could also, if I wanted to, let's change that back. I could add a different breakpoint in. For example, if I wanted them to come in at noon, maybe at noon they don't come in as fast. I can make them 300 seconds apart, whichever unit I feel like using. So at noon, they're going to start coming in every 300 seconds, and they're going to do that until they hit the next block, which is 5 o'clock. But in this case, I don't want to do it. I just wanted to show you the flexibility of this method. So I'm going to go ahead and get rid of that. And anytime I make a change, I either have to hit enter or click on a different line so that the change registers. So in this case, I'm going to have 1 minute apart all day long. In the approval area, I could change the rejection rate. I could right click on this, and there's going to be one for each level. If I right click here and say input editor, I could see the probability of being approved versus the probability of being rejected at this level. So approver 30% get rejected at level 1. I can make them any number I want as long as they're not negative, and the two add up to 1. So they have to follow probability rules. Here, I right click and say input enter. I have 80% being approved, 20% being rejected at level 2. So they've already gone through the initial screening. They're a little bit more likely to be approved. At the final level, I'm only rejecting 10% and approving 90%. Most of them, by the time they made it this far, will make it. I could change the amount of time it takes to do the decision. If I right click here and say input, I can see it takes between 2 and 5 minutes to make the level 1 decision, and I could change this to any unit I want. I can make it seconds or hours, whatever. At level 2, let's assume it takes a little bit longer. We're getting a little bit more involved. 5 to 7 minutes, uniformly distributed. And at level 3, we're going to take 5 to 10 minutes, uniformly distributed. As far as work shifts, I can control how many people are working. Right now I've got 8 working. So this model I made is you can do up to 8. And I've got 8 on at all the time. So at midnight I've got 8. Come 9 o'clock, I still have 8. And come 5 o'clock p.m., I still have 8. But if I wanted to make, say for example, say nobody works overnight, I can do that. And when you run the model, all 8 of these people will disappear until they hit 9 o'clock. Make sure you have at least one person work at some time, otherwise everything will bottleneck. Let's go change that back to 8. I could also put other breakpoints in. For example, I could put at noon. I could have them, if I wanted to, I could say at noon, everybody take a lunch break. like that. And now everybody will take a lunch break, and again, I'm back on from lunch. I would say at 1 o'clock, I would say all 8 of you come back. So now they'll take a 1-hour lunch break. So a very simple, flexible method to change my staffing schedules. In this case, I've got all 3 are going to use, I'm going to have 8 on it all the time just to keep it simple for our demo here. Here's my controls for the simulation. Let's go ahead and run it and take a look at what it looks like. So here you see a document coming in. He's deciding to approve it. It's going to take him between, I believe it was 2 and 5 minutes. Wrong one. Yes, 2 and 5 minutes. We could speed this up though because we don't want to wait that long. So I could go 64 times real time, so that won't take nearly as long. It's working its way down. And then it's going to work its way to the next approver. And then they'll leave the system. If any of them are rejected, they leave the system. And I'll show you where we keep statistics and stuff later. Okay, so now let's go ahead and look at the parallel. That's this view right here. In the parallel view, we're going to have the same 3 pools, and they're going to have the exact same workload coming in, so the exact same number of documents at the exact same times, and they got the same rejection or acceptance as the other, or approvals as the other one. So for example, if document 1072, if the random number came up and it was rejected in the series, it will also be rejected at level 2 here as well, if it was rejected at level 2 there. So we're going to compare apples to apples for fair comparison. When they come in, we're going to make a copy. So one's going to go to to level 1, one goes to level 2, one goes to level 3. All 3 of them are going to work on it, regardless of if they're approved or rejected at other levels. When they come out, they're going to wait for their partners, and then they get stapled together, combined, and reassembled, and then they leave the system. So when we recombine them, we're very careful to make sure that we combine your application with the copies of your application. We don't want to mix it up with somebody else's, so we're careful to do that. So we could go ahead and see this run. So now we got the same document, but it comes in 3 times, and we'll speed it up. And now they're waiting for their partners. They're normally going to be waiting for level 3 because that normally takes the longest. Occasionally you'll see a level 2 wait or a level 3 wait for another one, but not very often. And then they'll go out. Okay, so let's go ahead and clear that out. Let's slow this down. And I don't want to show you the answer in the next screen, so I'm going to run it just for a second. And now let's go look at both screens together. So here you got the series, and here we've got the parallel. I ran it just for a second, so we got one document in. We're going to keep track of how long it takes to get an approval. And right now, NaN means not a number, meaning none have come out yet, so it's got no number to display. And in parallel, the same thing. So let's go ahead and run this. And I'm going to speed it up, of course. Now the first thing you'll notice is that the parallel is already approving things, and the series hasn't even finished one yet. There, it just finished one. So it's taking a lot longer to go through the series. And if that was the only thing to the model, it would be a very boring model, but there's some definite trade-offs here. Let's continue to run it a little bit. And I think you're starting to notice that even though the parallel is finishing faster, about half the time, it's also, the people are a lot busier. If you just visually look at how busy they are processing, especially the downstream people. The reason for that is because they're working on things that would have been rejected and left the system in the series, but in the parallel, they're working on it. So this is very interesting from a lean perspective. If you Google Tim Woods lean. Go ahead and Google that or whatever search engine you like. And what you'll see is that's a mnemonic for the different kinds of waste and lean. So I'll leave it up to you to decide which kind of waste you'd like to call this. But what we have in this series is we got a type of weighting waste, because while it's being approved at level 1, it could be approved at level 2 and level 3, and it's not. So it's going to have to do it 3 times. So from a document perspective, it's very inefficient. But if we look at it from a workforce perspective, if we're the manager of this area paying the payroll, then we see we're paying people in level 2 and level 3 to work on approving documents that might have been rejected at level 1. So we're doing a lot more approvals than we need to be doing. We're doing more work than we need. That's why our people are so much busier. So it's a definite trade-off. And so let's think about what could impact that. The first thing we can do is, if we wanted to, we could play around with the staff levels. Now let's go ahead and do that. Let's see, could we reduce the staff level at all, say, to 7 people for the first 9 hours of the morning? If we ran this, what you're going to very quickly see and notice that the person disappeared. Okay, and it's the same in both models. They're both using the same controls. What we're going to see is that, I'm going to speed it up some more so you can see it. The parallel cannot keep up. They're overwhelmed, especially the level 3 people, because they're approving stuff that they normally wouldn't get, and it's just too much. Whereas the series can still handle it. And now their time is actually taking longer than the series. If we clear this out, and let's go put that person back in. I have to remember to hit enter or click on a different line so it registers. When I start the model, he'll reappear. Let's do this. Let's assume that the first 2 levels, that we had a very low rejection rate, almost 0. Okay, so 99% get approved, only 1% get rejected. And what's that going to do for us? Think about that. What do you think is going to happen? 0.01. Oops. Now what happened was I made a typo. I think I typed in 0.1 and it didn't like that. So it rejected me. So now I got 0.01. And that's actually a good thing to know that's checking that. Okay, so now what's going to happen, these first 2 levels, they're going to reject almost none of them. Let's go ahead and run it now. Okay, so you notice the other person came back. And we'll speed it up some. Now, that's having no impact at all on the parallel, because they weren't leaving the system when someone found a rejection, because they were matching them up. They were checking them all anyhow. But notice now the series is just as busy as the parallel, because they're all making their way through. So what you see the trade-off is that if you have a high rejection level, the series will be more efficient. But if you start approving most of them and very few continue on, then the parallel will keep up, because then they'll both have the same manpower requirement, but the parallel will do it much quicker. So if you're near 100% approval, go with parallel. If you're rejecting a substantial number, go with series. And if you're not sure where you fit on that, make a simulation model. So I hope you enjoy this. I really like this model that Bruce suggested, because it gave me some good trade-offs, and that always makes an interesting model.